This video is titled, How do you represent ionic bonding? If you are just starting the ionic bonding topic, I would recommend having a quick recap on atoms into ions, and I've got a video on my YouTube channel that talks you through that. So those two videos link really nicely into one another. To start off with, let's just talk about why ionic bonds form. So if you go back to the real principle of atoms, both metal and non-metal atoms, have incomplete outer shells. And what they do is they fill their outer shells to become stable. Now, what they can do is they actually can exchange electrons with one another. So, for example, you could have a metal losing electrons, which gives its electrons that it's lost to a non-metal, and that's what we see in ionic bonding. Now, as you'll go through, you'll notice that all the metal ions are positively charged and all the non-metal ions are negatively charged. Now, because you've got an atom with a positive charge and you've got an atom with a negative charge, those opposite charges actually attract together. And that attraction between two oppositely charged ions is called an ionic bond. And rather than call it an attraction between between a metal and a non-metal, we simply call that attraction an electrostatic force of attraction. Okay, now in ionic bonding, the main principle to remember is that you are always transferring electrons from your metals to your non-metals. Now let's look at sodium chloride. So you will be able to draw them as atoms really easily. Now you'll notice that my chlorine or my chloride on the right hand side, I've actually used dots or circles to represent the electrons. And the reason I do that, and it's the reason we do that in ionic bonding, because we're dealing with two different atoms, you draw one as crosses and one as dots. Okay, now you can colour in all of these dots in the chlorine like so. Okay, for the purpose of this video I won't have done that. Okay, you can see how long it takes me to do this, so I just draw mine as clear circles. But in diagrams and in exam, and what you can do as well, is you will have all of these dots coloured in. Okay, so you'll be familiar with drawing these as atoms, and if you've watched my previous video, you should be happy of drawing sodium and chlorine as two separate ions. Now, what you would have done when you did kind of just atoms into ions, you would have looked at the sodium, which is a metal, losing an electron. And when you are at the atoms into ion stage, you never actually know where that electron would go. So for example, let's just explain this a little bit better. This sodium would have lost that electron. So the sodium would lose the electron, it would turn into a sodium ion. And like I've said before, you never would have known where that electron went. You didn't need to. When you come on to forming ionic bonds, you need to understand that electron from the metal will go to a non-metal, and you can see that this is a perfect example where that transfer of electrons takes place. Now the chlorine or chloride ion has 7 electrons in its outer shell, and it wants to gain electrons. So what it does in sodium chloride, it takes that electron, or it transfers the electron from sodium to chlorine. Okay, those two atoms will now be oppositely charged and they bond together in an ionic bond. So you would then show, and again I'm going to draw all shells. In reality, in an exam, you actually don't have to. Okay, again I'll stick with my two colours. So my chloride had its original 17. Okay, and it's now got that 1 from the sodium. Sodium has got a positive charge because it's lost an electron. The chlorine has got a negative charge because it's gained an electron. So all you are really doing is drawing two ions side by side. And previously, when you were at the atoms into ion stage, you didn't know where the electrons came or where they went, okay? Now you can see why that was. You can see that the metals actually donate their electrons to the non-metals. So in this example, the metal is sodium, the non-metal is chlorine, and they form together in an ionic bond. Now, we will look at what an ionic bond kind of actually is from a bonding perspective in another video, but what an ionic bond essentially is just an attraction between a positive ion and a negative ion. So because these two ions are oppositely charged, they are drawn towards each other in an electrostatic attraction, and that is an ionic bond. In terms of representing ionic bonds, okay, we don't actually have to draw this little arrow between the two, okay? We just need to draw the two ions side by side, and that's enough. Let's look at another example, and I'm going to show you where we look at the loss and gain of two electrons. So you can see here that magnesium has got two electrons in its outer shell. Magnesium readily forms, or can readily form, a 2+ ion because it wants to lose those two electrons. We'll look at oxygen. Oxygen wants to gain two electrons. So nice and happily, these two electrons go over here. We create magnesium oxide. So drawing those as an ionic bond, or representing ionic bonding, we have magnesium that has now lost its two electrons. And because it's lost two electrons, it has a 2+ charge. The oxygen has its original 2 and 6, but it has its addition of the 2 from the magnesium. Okay, we then give it a 2- charge, magnesium oxide. Now, in my final example, I'm just going to kind of show you the next transition up in terms of ionic bonding. Now, if you look at the formula here, we've got MgCl2. That's a little bit different in terms of ratio of the previous two examples we looked at. So if you look at magnesium, obviously magnesium, the metal, has still got its two electrons in the outer shell. It is still going to form a 2+ ion. Well, if you look at the chlorine only needs one electron, okay? So both of the electrons can't go here, okay? It doesn't need it. What happens is that just one of the electrons goes here. Okay, so just one of those goes here. And what happens is we actually have two of these chloride ions like so. And that is where the other electron goes. Okay, so rather than having MgCl, we actually have MgCl2. Now, in terms of representing that, we still have our Mg, 2 and 8. Okay, with its 2+ charge. We then have chlorine, so we have chlorine with its original electrons. Okay, plus the one that it has gained from the magnesium. Now, you could draw two of those chlorine ions side by side if you really wanted to, but again, in exam questions, you just need to draw one ion of each. The fact that you've shown a 2+ charge on the magnesium indicates the fact that you know that there are 2 electrons lost from the magnesium for every 1 chlorine ion or chloride ion. Okay, so this slide here is kind of the next step up in ionic bonding, but that's kind of really as tricky as they get. Okay, so in like a 2-to-1 ratio, it's very, very rare, or do you actually see those examples, if at all, where you have kind of multiple ions bonding together. Okay, so you're still looking at the same principle. In ionic bonding, we are looking at the transfer of electrons from metals to non-metals. When we do that, we create positive ions and negative ions. They are drawn to each other in an electrostatic bond, and that is an ionic bond. And in terms of representing an ionic bond, you just simply have to draw your positive ion and your negative ion side by side.